Okay, so this lesson is all going to be on solving word problems, especially figuring out what to do when you see a word problem. So word problems are important because word problems in general show up all the time. In math problems, we see them as short stories that model the way we encounter math in our daily lives, but we also see real life word problems all the time. Whoops. So here are two examples. The first one says Fran is buying a gallon of milk for $1.92 and a loaf of bread for, oops, that should be 79 cents. If she pays with a $5 bill, how much change should she get? So that's a word problem that we would see in real life. Oops, sorry. That we would see in real life if you were going to the store and checking out. The second one says a school needs 420 masks a day for its students and teachers. How many masks does it need in order to have enough until November 1st? So again, these are problems that involve numbers that we encounter in normal life, and those are word problems. And we see these word problems, sometimes it's confusing because it doesn't look like a normal math problem, but just like normal math problems, there are ways to simplify them so we can solve them. So one way that's really effective to attack word problems is to really pay attention to what the words are saying. And we can do that by reading the problem 3 times, where every time we read the problem, we search for a different piece of information. And once we figure out what that information is, we're ready to attack the question. In other words, it's a little bit additional work up front, but then when we go to actually solving the problem, we know we're doing it right. We won't have to check it as much, and we're just going to be more confident in the answer. So the first time we read it, we ask ourselves, what is the problem about? That could be as simple as like, what is the topic? Like, what are we talking about? Are we talking about cars? Are we talking about shopping? Or it could be even a little more intense, like what math skills is it testing? Is this a problem involving percents? Is it involving decimals? What toolbox am I going to use? The second time you read, you can ask yourself, what am I trying to find out? So this means what is the problem solving? What don't we know? What units will be in my final answer? Often, what are you trying to find out is in the last sentence of the word problem. And you want to focus on that because that's going to help you tone in on only the information that's important and everything else you don't have to pay attention to. That leads us to our third question, which is what information is important? And the second part of what information is important is asking yourself what information is not important. A lot of time word problems throw in extra information that don't mean anything. They throw in extra numbers that we never have to use to solve our problems, but can confuse us if we just see numbers and try to find ways to put it together. So instead, we want to slow down and ask ourselves, what information is important to find my answer? What numbers am I given, and what do those represent? For example, if I'm given $5, what does that $5 mean in the problem? How can these numbers help us solve the problem? And lastly, what keywords do we have? Other than numbers, what language does the problem have that tells us what we're going to do? So we're going to practice kind of answering these 3 reads, and then we will see how we can apply that to solving problems. But the first practice problems are just on doing the 3 reads, not even solving. So this is the first problem. It says, at a garage sale, Joanne bought a vase for $6, a picture for $12.50, and a lamp for $9. How much did Joanne pay for the vase and the lamp? So the first time I read it, again, I'm just saying, what is this problem generally about? And I see it's about buying things. It's about shopping. So just about going to a store and I see that there's money involved. That might help me think like maybe my final answer should have a dollar sign. I'm going to read it again. This time I'm going to ask myself, what am I trying to find out? So I'm not going to pay attention to anything else in the question. I'm just looking for that one piece of information. It says, at a garage sale, Joanne bought a vase for $6 and a picture for $12.50 and a lamp for $9. How much did she pay for the vase and the lamp? All I'm looking for this time I read is what I'm trying to find out, and that's in the last sentence. I'm looking for that total cost of the vase and the lamp. So I'm going to put that in there. I want to know the cost of the vase and the lamp. And I'll read it one more time. This time, I want to find what information is important to find the cost of the vase and the lamp. At a garage sale, Joanne bought a vase for $6, a picture for $12.50, and a lamp for $9. How much did she pay for the vase and the lamp? If I want to know the cost of the vase and the lamp together, I need to know the cost of the vase and the cost of the lamp. So I'm going to write that down. Notice when I wrote it down, I didn't just write $6 and $9. I wrote what each of those numbers represent, and that's going to help me if I were to go to solve through this problem so I could add them together. So that's all the 3 weeds look like. We're going to try it with 2 more problems and then go into actually solving these. This is a new problem. On Taylor's 12th birthday, he weighed 109 pounds. During the next 2 years, he gained 17 pounds. Then, between his 14th and 15th birthdays, he gained another 11 pounds. How much did Taylor weigh on his 14th birthday? So I just wrote it one time, and all I look for that time is I want to know what in general did I read? What's it about? Well, I think that it's about weight. There was weight change in the problem. So that's all I'm going to write. This time when I read, I'm looking for what I want to find out, what my final answer look like. On Taylor's 12th birthday, he weighed 109 pounds. During the next 2 years, he gained 17 pounds. Then, between his 14th and 15th birthdays, he gained another 11 pounds. How much did Taylor weigh on his 14th birthday? Just like the last question, I see what I'm trying to find out in the final sentence of this word problem, and that's a common trend. It's not always true, but it does happen a lot. I want to know that final weight on his 14th birthday. And that's helpful because I know if I'm looking for weight, maybe my unit's going to be in pounds now. So I'm starting to think about units. This time I'm going to read for what information is important. You'll notice there's a lot of different numbers in here because we got birthdays and pounds. We're going to zone in on only the information that's important to get us up to that 14th birthday weight. On Taylor's 12th birthday, he weighed 109 pounds. During the next 2 years, he gained 17 pounds. Then, between his 14th and 15th birthdays, he gained another 11 pounds. How much did Taylor weigh on his 14th birthday? So I'm looking for how much he weighed on his 14th birthday. So I want to see what happened before he turned 14. And I see when he was 12, he was 109 pounds. So that's important. So I know his starting weight. And then I see that during the next 2 years, so from going from 12 to 14, he gained 17 pounds. So I also knew how he changed. The problem keeps going and says what happened between his 14th and 15th birthdays. It said between his 14th and 15th birthday, he gained another 11 pounds. But is that important to us if we only want to know how much he weighed on his 14th birthday? No, this whole middle sentence here is not important because it's talking about something beyond his 14th birthday, which is not what we're interested in. It is excess information that is just there to confuse us. So you can, when you see that, you can cross it out. I'm just going to delete it because that is not relevant to the problem. And that's why it's so important, because now I know the numbers that I'm actually going to be working with. I'm going to read it one more time, one more question before we go into actually solving questions. This question, again, the first time we read, we're just generally thinking, what is it about? What's like the main idea here? Kind of just like we're reading. While on a special diet, Grace ate 1,500 calories each day, 1,300 fewer calories than her regular 2,800. The typo. On this diet, how many calories does Grace eat each week? So I just read it once. I'm going to have to read it again because there's a couple big numbers in there, but I know generally we're talking about calories and something about diet. There's a diet going on. I filled in the second and the third one already, but we can read it through and see where we got this information. So the second time we read, we want to know, what am I trying to find out? And it says, while on a special diet, Grace ate 1,500 calories each day, 1,300 fewer calories than her regular 2,800. On this diet, how many calories does Grace eat each week? So again, in that last sentence, my final question says, how many calories? So I know I'm looking for, my unit will have calories, are eaten each week on the diet. So those are all pieces of information that my answer should include. And then lastly, I'm going to go back and be detective and look for what information is important to find that. So read it one more time. While on a special diet, Grace ate 1,500 calories each day, 1,300 fewer calories than her regular 2,800. On this diet, how many calories does Grace eat each week? So if I want to know the number of calories she eats on her diet per week, I'm going to go back and see what's going to help me. Well, how many calories does she eat on her diet? It says while on the diet, she eats 1,500 calories each day. So that's something about how much she eats on her diet. I'm going to write that down. And I didn't just write 1,500, I wrote 1,500 calories per day. Now I'm going to step back. I want to find out the number of calories in the diet per week. Well, if I know something about the days, I can find something about the weeks because I know there's 7 days in each week. And then I'm going to stop. The rest of this information in this first sentence is not important because it's not talking about the diet anymore. That's why it was so important to read it 3 times and figure out what I want to find out, because all of this information I have highlighted does not talk about our diet, so we don't care about it. So we can cross it out, we can delete it, because that's all distracting for us. So even though this is like repetitive at the beginning, at the end, when we're ready to solve now, you'll see that it makes it very clear on what we're going to do. So that's one big part of figuring out how to approach word problems. We want to know what's important and what's not. The other thing we have to figure out is what are we going to do once we have the numbers? I know what numbers I'm using. What do I do with them? Will I add, subtract, multiply, or divide them? That's the next step. We want to use all of this information to pick out operation, to figure out what we're going to do. And when I say operation, I mean, are we going to add, subtract, multiply, or divide? In that last step, you have those numbers that are important, but what are you going to do with them? Just add them all together, subtract them all, multiply them? You got to figure out what. In some problems, you just have to pick the operation and put the numbers together, but sometimes we also get multi-step problems, which involve more than one step, but we have to perform maybe 2 of those in an order. So we sometimes can only pick one operation, sometimes we have to pick 2. And when we do this, once you read it 3 times, the good thing is you have a good intuitive sense of the problem. You know what it's talking about. It's not like you read it once and you're like, wait, what? Like you've spent a lot of time with it. So you might just know what to do. It might make sense. But other times it might not be as clear. So we still have strategies. And our big strategy here is that other times we are going to look for keywords, which are words that give clues on how a problem can be solved. Often you'll come across these keywords in your 3 reads and you will include them in that step that says what information is important. Not every problem has a clear keyword that means, hey, I see total, that means add. But often if you read it 3 times, you can infer or figure out what that keyword is, and then you'll know what to do. So before we practice this, I want to give some examples of this in this list here. Sorry. So we have our 4 operations, our addition, subtraction, multiplication, and division. And each one of those words has many different words that are clues to us that say, hey, if I say increased, I mean add. If I said difference, I meant subtract. If I said times, I meant multiply. If I said average, I meant division. We use all of these key words without actually saying, hey, multiply. That's kind of the whole point of word problems. But luckily, when we read the problems multiple times, we don't just have to straight memorize this list. Like I said, a lot of times you have intuitive understandings of what's going to happen, or you can think about what's going on in the problem. But if you keep these keywords in mind and get more and more familiar with them, it's going to be kind of a way to be confident in your work. So you can come back to this list if you need to when you're watching. But now we're going to practice. If we want to understand what a keyword means, we should also be able to pick our own keywords. So we're going to practice working with these keywords and then put it all together for problems at the end. Our directions here say complete problems 1 and 2 by choosing the word problem that makes each problem an addition problem. So I'm adding and then solve them. We're actually just going to fill in the keywords on this step. We'll solve them later. So we're going to read question 1 and figure out what word do I need to make it an addition problem. It says Lucille planned to spend about $35 on a new sweater. Instead, she found one that cost $8 blank. How much did Lucille pay for the sweater? Well, if I know I'm adding something, I know my number is getting bigger. So I want to pick, if I'm choosing between less or more, I know more means that's adding on in addition to. So I would fill in that blank with more. Number 2 says, on June 1st, AMD computer stock was valued at 46.5 points per share. 2 weeks later, the stock's value blanked by 2.5 points. What was the new value of the stock? Again, between rose and fell, I want to think about what word means that the number is getting bigger because I'm adding, and that's going to be rose. So even if I didn't see rose or remember rose from that list, I know that's a keyword for addition. So if I saw that in the problem, I could decode that and say, hey, you need to add. We can also do this with subtraction, so the same thing, but now we're going to think about how to subtract. What keywords would we pick for subtraction? Last year, Scott drove his pickup truck a total of 8,500 miles. This year, he intends to drive it 1,500 blank miles than last year. If he does, how many miles will he drive the pickup this year? When I'm subtracting with positive numbers, my number should be getting smaller. So if I'm choosing between fewer and more, fewer is going to give me that smaller answer. So I know it's fewer. Marnie usually works 3.5 hours of overtime on Saturday mornings. This Saturday, though, her boss wants her to leave work about 3/4 of an hour blank. How many overtime hours will Marnie work this Saturday? This is kind of a tough one. But if we think, okay, usually that total amount is 3.5 hours. And now we have to leave 3/4 of an hour. What would we have to leave earlier or later to make that number smaller? If I'm subtracting, that's the same thing as taking away time. So I have to leave earlier. I have to take away time from that 3.5 hours. So that is earlier. Now, just like addition and subtraction have keywords, multiplication and division do. So number 5 says, on Tuesday, Frank moved 12 tons of fill dirt to the construction site. On Wednesday, he plans to move blank this amount. How much dirt does Frank plan to move on Wednesday? If I'm multiplying, I'm deciding between 1 and 2 now. 1 says 4 tons less than, and 2 says twice. Well, twice to me means times 2, so that sounds good. And 4 tons less than to me sounds like subtraction, which doesn't sound good. So I'm going to pick twice. Number 6 says Cami and 2 friends had lunch together. They ordered 3 lunch specials that cost $4.95 each. But before going to pay the bill, Cami said to her friends, I'm going to blank the bill. What answer should Cami get? If I'm multiplying, it should be getting bigger. If it's $4.95 each and there's 3 people, that's the same thing as adding $4.95 3 times or multiplying it by 3, which means she needs to total the whole thing together. And lastly, division is the last common operation we see. It also has its keywords. Sometimes division keywords can be sneaky, so let's try these 2. Number 7 says James started with 9 pieces of rope. Each piece was 6¼ feet long. He then cut one of these pieces into 3 equal parts. What is the length of the blank of rope James has? If I'm dividing positive numbers, my numbers should be getting smaller. I'm splitting a whole into parts. So I'm not looking for a total, but I'm looking for one of those parts, and that part is the smallest piece. Lastly, Cheryl is driving across the country. She drives for 5.5 hours each day. The first day she drove a total of 264 miles. Driving at the same rate, how far can Cheryl drive each blank on the average? Well, again, I'm trying to find a part. So if my whole here was 5.5 hours and I'm dividing it into parts, I have to look for hours because hours are a part of 5.5 hours and weeks are bigger. So we can think about division as like that part to the whole. So now we're going to try a few problems putting it all together. If we do our 3 reads and identify keywords, we have enough information to solve problems. And what that means is we want to turn these math sentences, these math short stories, into normal problems that we're used to seeing. So I'm going to read this problem again using the 3 reads. Each time I'll ask myself a different question. The first time I read, I'm going to ask myself, what is the problem about? It reads, what is the total of John's $425 rent bill, $133.75 car payment, and $48.50 telephone bill? In this problem, I see that I'm paying bills. In general, it's about paying bills. I'm going to read it one more time. This time I'm going to ask myself, what am I trying to find out? It says, what is the total of John's $425 rent bill, $133.75 car payment, and $48.50 telephone bill? Well, I highlighted this word total. Total means put it all together. So I'm going to find out that total bill, and right next to it, it doesn't have a key, it doesn't say add, but total is a keyword telling me to add. So I'm going to tell myself at the end, I'm trying to find out some addition problem. And if I want to find the total, I need to add all of it together. So if I were to read it one more time, I would see that each of these numbers are important because I have to put them together to find a total. So I'm adding that rent payment, that car payment, and that phone payment. And I can say that the total is the sum or adding all 3 of them together. So I can take this math short story, and in the bottom here, I can turn it into an addition problem. First, in words, I said the total equals the rent bill plus the car payment plus the telephone bill. If you can write a math sentence, a math word problem into words and then turn it into numbers, then you'll make sure that everything's lining up, that we're using numbers the way that they should. For example, it would be incorrect if I said the total bill was $425 just because I saw that number. But in all, I identified my keyword as total. I did my 3 reads. Now I know that I'm adding. I add the 3 together, and I find that it's $607.25. We'll just do 2 more problems using the 3 reads and keywords. This problem says Yoshi lost 20 pounds in 8 months. On average, how many pounds did Yoshi lose each month? So in general, the first time I read it, I noticed the problem was talking about weight loss. This time when I read, I'm going to see what am I trying to find out. Yoshi lost 20 pounds in 8 months. On average, how many pounds did Yoshi lose each month? Like usual, what am I trying to find out is in that last sentence. And it says how many pounds were lost each month. So I know my answer will have pounds, but not just any amount of pounds. The pounds lost each, I wrote week here, that should say month. And now I'm going to go back and read it one more time and ask myself what information is important for me to do that. It says Yoshi lost 20 pounds in 8 months. On average, how many pounds did Yoshi lose each month? Well, I see that there are 20 pounds in 8 months, and that seems important to me because I know my final answer is relating pounds to months. But I don't know how I'm going to get there. But I do see this keyword average, and I'm going to write that down as something that's important too. Average is a common keyword that tells me to divide. When I see average, that's telling me I need to divide 20 pounds into 8 months to find the unit rate of pounds lost per month. So now I have enough information to turn this in to a problem. Average means divide, so I know that 20 pounds over 8 months is going to tell me how many pounds are lost in 1 month, which is what I'm looking for. If I do 20 divided by 8, I find out that on average, Yoshi lost 2.5 pounds in each month. And because this is a word problem, I can put it all together in one sentence where I'm going to restate the question. So the question said, how many pounds did Yoshi lose each month? So I'm going to say Yoshi lost, and now I solved. I know it's 2.5 pounds in each month. So my final answer there will look like a sentence, just like the word problem. And one more. This problem says, since noon, the temperature has fallen 19 degrees. What is the temperature now? where'd it go? There it is. What is the temperature at, sorry, I'll try that again. Since noon, the temperature has fallen 19 degrees. What's the temperature now if the temperature at noon was 72 degrees Fahrenheit? Here I did the 3 reads already, and I noticed the first time I read it that the problem is about a change in temperature because it's telling me about temperature changes. I'm trying to find out the temperature now or the current temperature. If I want to know the current temperature, I want to know what was the temperature like before right now. Well, it says at the end here, this time there's important information at the end. It says that my temperature at noon was 72 degrees. That was my initial temperature. And then it says the change was 19 degrees. But it doesn't just say change, it says fallen. Fallen is a keyword telling me it decreased or it went down or it was negative. And that's a keyword telling me that I'm going to subtract. It doesn't say subtract, but fallen tells me that it decreased. So I'm going to take away the change from the initial. So I get 72 minus 19, and that equals 53. And I can put that in a sentence saying the temperature now is 53, and not just 53, but 53 degrees Fahrenheit. And that's my final answer. So in each of these problems, when we're confronted with these word problems and math stories, our big focus is to pick the right operation to turn these complicated math stories into problems like this one right here, this sentence, simplified to really just a simple subtraction problem. And to do that, we want to do the 3 reads. That's the early work that's telling us now I'll know how to set up the problem. So again, we ask ourselves, what is the problem about? What am I trying to find out? What information is important? Through that, we find out what keywords we have, what operation we're going to use, and then we can solve it.